Hi, Mr. Richards here. Today's lesson is on simplifying rational expressions. A rational expression is an algebraic fraction whose numerator and denominator are polynomials. So we'll get some extra practice with our polynomials in this lesson. The first example deals with stating excluded values for each rational expression. And similar to our previous lesson, when we were working with rational functions and finding excluded values of those, with our rational expressions, we're still going to set our denominators equal to 0 since division by 0 is undefined. So in our first example here, example A, we can take our b plus 7 and set it equal to 0. Subtract that 7 away from both sides, and b is going to equal negative 7. So negative 7 is an excluded value for this expression. What about the next one? Well, here we need to set a squared minus a minus 12 equal to 0. Well, there's only one thing to do here, and that's to factor. So we're looking for a product of negative 12 that adds up to be negative 1. And what about negative 4 and positive 3? Those multiplied to be negative 12 with a sum of negative 1. So we can then factor this into a minus 4 times a plus 3 and set that equal to 0. And by using the zero product property, we can then state that a minus 4 equals 0 and a plus 3 could equal 0. Well, if we add 4 on the first one here to both sides, this could cancel. We're left with a equals 4. And in the second one, subtract 3 from both sides, and you'll be left with a equals negative 3. So in this example B, a cannot equal 4 and a cannot equal negative 3. Those are excluded values for this expression. What about our last example here? Give some space there with some pretty dividers. 2x plus 1 is our denominator, so we can look at 2x plus 1 and set that equal to 0. Two-step equation here, so if we subtract 1 from both sides, we are left with 2x equals negative 1. And if we divide by 2, we're left with x equals negative 1/2. So this excluded value is negative 1/2. Find the height of a cylinder that has a volume of 770 cubic inches and a diameter of 12 inches. Round to the nearest tenth. Well, our formula here, volume equals pi r squared height, is how we can find the volume of a cylinder. To find the height of a cylinder, if we were to divide by pi r squared on both sides, we would then have the formula volume divided by pi r squared equals the height. So if we go to make substitutions in, we're given a volume of 770 divided by pi times our radius, which is 6, because half of 12 is 6. The diameter of 12 means we have a radius of 6 squared. And that's going to equal our height. And if we take 770 and divide it by pi times 6 squared, we're going to get about 6 8/10 for our height. So 6 8/10 inches is our solution to this question. In example 3, we need to simplify a rational expression using the greatest common factor of the numerator and the denominator. So we have simplified the expression 32x to the 5th y squared over 4x y to the 7th. Our first step is to factor the numerator and denominator using the GCF. So let's take out the GCF, and if we look at the 32 and the 4, the GCF here is 4. So we can say, okay, we're going to take out a 4 from both. What about x to the 5th and x? Well, it's just a single x. And what about y squared and y to the 7th? Well, that's just y squared. So we're going to be taking out the GCF 4xy squared out of both. And what does that leave us with here? Well, from the 32, if we take out a 4, that's just 8. And from x to the 5th, if we take out 1x, that's x to the 4th. And for the y squared, when we took out a y squared, that leaves us with just the number 1. So it's just 8x to the 4th on top. On the bottom, if we look at this 4, what did we take out here? Well, a complete 4, so we're just left with 1, so that's nothing. The x, we took that out. And for the y to the 7th, we take a y squared out, so we're just left with y to the 5th. Well, these cancel out. And so we can write a simplified expression here, 8x to the 4th over y to the 5th. And that's our final answer, 8x to the 4th over y to the 5th. In example 4, we need to simplify the expression and state the excluded values of the variables. Well, first let's do the excluded values. You could do this in any order. You could simplify, then go to excluded values, but let's do the excluded values first. Define this. Take your denominator, x squared minus 5x minus 36, and set that equal to, well, 0. We need to factor the expression x squared minus 5x minus 36 now, and if we look at a number that multiplies to be negative 36 with a sum of negative 5, we could use the numbers negative 9 times 4. That multiplies to be negative 36 with a sum of negative 5, and so this becomes x minus 9 times x plus 4 equals 0. And using the zero product property, x minus 9 equals 0 and x plus 4 equals 0. Add 9 to both sides and x equals 9. Subtract 4 from both sides and x equals negative 4. So we're going to have excluded values here of 9 and negative 4. And we'll get back to those in a minute. But let's now see if we can simplify our expression. And that's the other part of this. So 4x plus 16 over x squared minus 5x minus 36. Let's see if we can factor this out. For 4x plus 16, we can pull out a 4. So we can say, okay, that's going to be 4, and then x plus 4 after we pull out that 4. And then the x squared minus 5x minus 36, it's kind of convenient here now because we've actually already factored this out over here. And so we have x minus 9, x plus 4. And now a cool thing happens. Since we have all multiplication here, we can divide out these two common factors, the GCF. And so that simplifies, and we're left with 4 over x minus 9. And that's the expression simplified. Now, to write our final answer, the way we're going to write this now is to say, well, this simplifies into 4 over or divided by x minus 9, and we'll use our semicolon. As long as x is not equal to negative 4 and x is not equal to 9. That's how we're going to bring in the excluded values. In our fifth example, we're going to see the importance of recognizing opposites here, but we'll have simplified the expression again and state the excluded value of the variables. Well, let's look at the excluded again. And one reason why I'd like to look for the excluded values first is because you use the denominator of the original. You always want to use the denominator of the original expression, not the simplified expression, and set that one equal to 0. And so if you do it first, you're not going to have to worry about getting it confused. Just find the excluded values first and then simplify your expression, is the way I would do it. So if you add 40 to both sides here, you get 8x equals 40. Divide by 8 and x equals 5. And so that's going to be an excluded value for our expression. And now we get to simplify. And there is a correction that needs to take place here. I mistyped that plus sign in there. I'm going to cross out this question and say, okay, this is supposed to be 25 minus x squared over 8x minus 40. Little mistake, just make that correction, and now we can continue with our question. Now if you remember our differences of squares rules from Chapter 8, Lesson 8, it would help us factor 25 minus x squared since both are perfect squares. This stated that if you had a squared minus b squared, that this could simplify into a minus b times a plus b, which helps us here because then we can write this as 5 minus x times 5 plus x, since the square root of 25 is 5 and the square root of x squared is x. And on the bottom now, for the 8x minus 40, if we factor out an 8, that gets us 8 times x minus 5. Now this is where the opposites comes in. If I can rewrite here the 5 minus x as negative 1 times x minus 5. In other words, if I multiply both of those by a negative 1, this then becomes negative 1 times x minus 5 times 5 plus x over that 8 times x minus 5. And why does this come in handy? Well, I can simplify this and this here. So that now I have negative 1 times 5 plus x over 8. So now I can rewrite this pulling out that negative 1 here to the side. So negative of 5 plus x all over 8 is our solution as long as x is not equal to that excluded value over there of 5. The big thing in this question is recognizing that I needed to use opposites here. I had an x minus 5 down here that I wanted to simplify with something up here. And so if I multiplied the terms here or divided out a negative 1, that made it possible then to simplify. In our last example today, we have find the zeros of the function. Well, our first step is pretty easy. We're going to put in 0 for f of x. So this then becomes 0 equals x squared plus 3x minus 18 all over x minus 3. And now we get to factor. If we're looking for something that multiplies into negative 18 that has a sum of 3, this would be positive 6 times negative 3 is negative 18, and they add up to be 3. So this is going to now break into x plus 6 times x minus 3 all over x minus 3. Well, the bottom x minus 3 simplifies with the top x minus 3, and we're left with 0 equals x plus 6. And if we subtract 6 from both sides of the equation, we're left with negative 6 equals x. That is the 0 of this function. So when x equals negative 6, the numerator becomes 0, so f of x is 0. Therefore, the 0 of the function is negative 6. And that's it for this lesson on simplifying rational expressions. Good luck.